Let's do problem number 238, product of array except self. So we are given a an array, and we need to return an array such that each element of the output array represents it has the product of the whole array except the number at that index. So let's if in the answer the index is 0, right? At 24 it is 0, and then 0 here is going to be 1. So this should have the product of the whole array except this one, right? So 2 times 3 times 4 is going to be 24. So that's the idea. And then so let's say for 3, right, 8 is 4 times 2 times 1, which is 8. So if we were looking at 3, it's 0 1 2, right? 0 1 2. So this contains the product of the whole array except this one. So we could be clever and say, you might think we could just multiply all the elements, and then at each you could just divide it, right? But if you notice, there's going to be zeros, right? So if there are zeros, then that's going to be a problem. Multiplying with 0 is going to result in a 0, right? And if this was a 0, or let's say this was a 0, right? So this is a 0, and the product of everything except itself is going to be 9, not a 0 divided by 0, right? So if you take the whole product, if you take the product, it's going to be a 0, and we might and you're thinking, okay, 0 divided by minus 1 is 0. Yeah, it's going to be fine until here, but when you reach this index, it's going to create a problem, right? Because the product of the whole array except this one is not a 0, or not a 0 divided by 0. So for this problem, you could use something called a prefix suffix array. So it's essentially the product until this number, or the product until this number, and then suffix is going to be product until this number from right side, right? So if you have that information at that index, you will have the information about the product from here to here and then here to here, right? So we can start coding, and prefix is going to be nums dot new and nums dot length, copy and paste, suffix, right? And then answer is going to be new and nums dot length, because we're returning an array, and we're gonna pre-fill. So the very last element in the suffix is gonna be let's say it's okay. So for this one, right, it's gonna be a 1, because everything, the product after 4 is 1, right? and then the product before, we're going to initialize it with a 1, right? So prefix or you could just do you could just do that. Prefix 0 equals 1. And then we're gonna iterate from for the prefix, we're gonna iterate this prefix. For this one, we're gonna iterate from nums.length minus 2 and I equals 0. Let's do the prefix first. For prefix, we're gonna iterate from 1. I less than nums.length, I plus plus. Answer I equals, oh no, I'm sorry. Prefix I equals prefix I minus 1 times nums I minus 1, right? So this times this is what's going to be here. So 1 times 1 is 1, right? Like 1 times 2 is 2, and then 2 times 3 is 6, and then here it's like 1 times 1 into 4 is 1 times 4 is 4. 4 times 3 is 12, and then 12 times 2 is 24. That's all we need. And like now you can see, like, answer, we're gonna have 24 times 1 is gonna be 24. 12 times 1 is 12. 4 times 2 is 8. 1 times 6 is 6. So it checks out, right? It's the same as this one. So, and now we do for int I equals nums.length minus 1 minus 2, because we're starting from here. That's what we start from here and then filled up until here, right? So this is nums.length minus 1, this is nums.length minus 2. So we're going to start from here. I greater than or equal to 0, I minus minus, suffix I equals suffix I plus 1 times nums I plus 1. And then for int I equals 0, else then answer.length I plus plus, answer I equals and prefix I times suffix I. This should give the right answer, right? So return. Perfect. All right, so that's the whole algorithm for this one.